Right, we are beginning our discussion now, focusing on the external examination that was written by some students at actually a school, Lower Big Reach Primary School, in 2019, and we are looking at how we can be in a position to do this in our discussion today. Mathematics paper 2, and the examiner is here, the instructions. Strictly, no calculators may be used, so you're not allowed to use calculators. Read through your questions carefully, write neatly and legibly with a sharp pencil. Once done, go through your paper to check all your answers again. Okay, we are there. Right, so we're going to be looking at first at section A. Section A is about two-dimensional shapes, 2D shapes, two-dimensional shapes, triangles, and angles. Let's get started. Section A says, study the shapes below and answer the questions that follow. Study the shapes below and answer the questions that follow. Right, if you look at 1A, we have this shape here, and we have that shape there. Okay. And now, here is the question. Identify the two quadrilaterals. Identify the two quadrilaterals. What do you think Roman figure 1 is? This one here. What do you think that is?
It's a rectangle.
Well done. It is a rectangle. Okay, so we have a rectangle. What do you think this one is?
A parallelogram.
Well done. It is a parallelogram. It's a parallelogram. Right. That's correct. So give one similarity between the two quads. Okay. What is the similarity, one similarity between the two quads? What is the similarity between these two? In what way are they two similar?
Their opposite sides are equal.
Good. Both quads have opposite sides equal. Give one difference between the two quadrilaterals. There is a difference between the two quadrilaterals. What is the difference?
They are not 90-degree angles.
Okay, good. All right. One thing that we know is that your rectangle, that's correct, you're right. A rectangle has two lines of symmetry. Parallelogram has none. So a rectangle has two lines of symmetry, a parallelogram has none. So that is one distinction, but also you can note that each of the interior angles here are actually equal, but in the case of this, the opposite angles are equal. So in a rectangle, each angle is 90 degrees is 90 degrees in a rectangle? Here you come and say the opposite. Angles in a parallelogram are equal. But not necessarily 90 degrees. Okay, you can say a rectangle has two lines of symmetry. Namely, a line of symmetry would be this. Another one would be that. Can have multiple lines of symmetry. So in other words, now we actually can see that we have no line of symmetry in the case of the parallelogram. Next question. Study the triangles and answer the questions that follow. Identify the following triangles and give a reason for your answer. Okay. So here you can say that rectangle has at least two lines of symmetry, because you can count 1, 2. You can count 3, 4, etc. Okay, so has at least two lines of symmetry, whereas a parallelogram has none. Right, if you look at 2, for example, study the triangles and answer the questions that follow. Right, here's one triangle that has all the sides equal to each other. Here's a triangle that has a right angle inside, and here's another triangle here. Okay, yeah, this triangle appears to have moved. Yeah, we're gonna sort that out, because you can see that these marks were potentially parts of, were markings on a triangle. Okay, so we continue. Identify the following triangles and give the reason for your answer. Like in 2.1, Roman figure 1, you need to identify the following triangles and give a reason for your answer. Right, what is Roman figure 1, this triangle? What is it? What is the reason as well? What do you think?
Says it congruent.
Okay, all the sides are equal to each other, and therefore it's called equilateral. It's called equilateral. Why is it called equilateral? All sides equal, or all sides are the same. All sides are the same length. Okay. Okay, now what do you think shape 2 is? Because we need to identify the triangle. What is it called?
Is it yes.
Okay, it is called right-angled.
Oh, right-angled.
It is called a right-angled triangle. We call it a right-angled triangle. The reason for the answer is that it has one. It has only one right angle. There's only one right angle. Okay, Roman figure 3. What do we call this shape? Okay, so I was saying these things have moved. So yeah, these markings are supposed to be on the sides there. What do you call the shape? Triangle Roman figure 3. What is it called?
Sir, is it a isosceles?
It's called an isosceles triangle. It is called an isosceles triangle. Why is it called isosceles?
Because it has two equal sides.
Yeah. Two sides equal because it has two sides equal. Or you can alternatively say two angles equal. Okay, 2.2. Calculate the size of angle A to D, right through to D. Okay, let's check this one. Calculate the size of angle A to D. What is angle A in your view? What is the size? We're looking for the size of angle A. What is the size of this angle?
Let's see. Okay. Yes.
What do you think the size is?
Says it 40.
Well, a triangle that is called equilateral with all the sides equal, all the angles are equal. So each, yeah, all the angles are equal. If you add them up, they give 180 degrees. So each one must be 60 degrees. So in other words, A is equal to 60. A is equal to 60 degrees because 60 plus 60 plus 60 is equal to what?
180.
180 degrees, and that is the sum of the interior angles of a triangle. The sum is 180 degrees. Next, okay, B. What is the size of angle B?
Angle B. Says it 48.
Why?
So, because you need to add up the 90-degree angle plus 42.
Yes. Okay. Yeah, but need to check. So in other words, we'll have B plus, so we'll have B plus 42 degrees plus 90 degrees is equal to 180 degrees. This is the sum of the interior angles of triangle. So B is equal to, what is 42 plus 90?
132.
132 degrees equals 180 degrees. Next. So B is 180 degrees minus 132. What is 180 minus 132?
48.
Okay. 48 degrees. All right, so that's noted, 48 degrees. So in other words, B is 48 degrees. Well done. Okay. Next, what is C?
Okay. 60. Is it 65?
Well done,
Degrees.
65 degrees. Why?
Because isn't it an isosceles, meaning
Yeah, the reason
that
of this is simply because if you check very carefully, it is isosceles, and therefore this angle must be equal to this angle here. And this one, they've just put C there for it, but it must also be 65 degrees. What is D?
so where is D?
That's a good question. Where is D? Where is D? Okay, I'll just show you now. Okay, I'll just show you now where D is. Okay. Right. D is here. What is D?
Let me calculate. So is D wait, so is D 50?
Please come again.
50.
Why?
65 plus 65 equals 130 plus 50 gives you 180. So
Okay, so that's 130 plus 50, which is 180. That's correct. Well done. Excellent. Next question. Right, let's look at 2.3. Calculate the missing angles in the following diagrams. A, B, C. According to you, what is the size of angle A and why?
angle A, so is it 55?
Why?
So because this is a 90-degree angle, so you need to add up angle A
Well
plus
done. It is
35.
5 degrees. 5 degrees, because it must add up to 90 degrees with a 35. Correct. Okay, what is B? This
So
one.
90.
B.
So it's a 90-degree angle.
B is actually a 90-degree angle. Well done. C. What is C? Okay. We are thinking about C. We are thinking about C. What's the answer?
Is it 110?
Why?
So does this need to add up to 360? So I added up all of the numbers 80 plus 100 plus 70, which gives us 250. Then 250 plus 10, 110 gives us 360.
Okay. I hear you. Let's just check that. I mean, you really are on point. You really are on point. C is 110. C is 110 degrees. Next, measure the following angles using a protractor and identify what kind of angle each are. All right, this is going to be tricky because you don't have the question paper and now you're just seeing it on screen, but you know how to use a protractor.
Yes, sir.
All
I
right.
have mine with me.
Okay. Okay. All right. Yeah, but it's a skill that you need to learn, but it's okay. It's okay. So I'm gonna give you the sizes, okay? Because if you use a protractor and you get 49 here, you get 49 here, and then we get 94 degrees here, and here we get 217. And then B is 94. Okay, so the kind of angle. What is the kind of angle that is 49? What do you call that kind of an angle?
An acute angle.
It's called acute. Well done. It's called acute. It's called an acute angle. 94 degrees. What kind of an angle is that one?
An obtuse angle.
It is called obtuse. It is called obtuse. C, what do you call that angle?
A reflex angle.
It's called reflex. It's called reflex. I mean, I heard 217, but it's called reflex. This is called the reflex angle. Okay, it's called the reflex angle. Next. Okay, if you look at 3.1, complete the table below. Complete the table below. If you look at the 3D object, the name must be given, the number of edges, the number of faces, the number of vertices. Okay, we're discussing this paper together. What do we call the name of this 3D object? This one. What do you call this? What is the name of this?
So is it a pentagon?
It is called a, because it is 1, 2, 3, 4, 5. The top and the bottom have 5 vertices. So it is called a pentagonal prism. Pentagonal prism. Number of edges. How many edges are there?
Edge. 5.
Okay, let's count. So this is an edge. That's 1, 2, 3, 4, 5. The top has 5. The bottom has also 5.
Oh,
Okay, because you have 5, then you have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In other words, the total of 15 edges. 15 edges. How many faces are there?
uh, 7.
Please come again.
7.
7 faces. Well done. Excellent. The total of 7 faces. How many vertices are there? How many vertices are there?
So 16.
Okay. How did you reach that? Anyway, a vertex is a corner. So yeah, this is a vertex. 1, 2, 3, up to 5, and then 5 at the bottom. 5 at the top, 5 at the bottom. So the total of 10 vertices. Total of how many? 10 vertices. Okay. Okay, now in the bottom shape, what shape is this called? This one. It's called a three-dimensional object, but what is the name of this shape?
Is there an octagonal pyramid?
It is called an octagonal pyramid. Excellent. Octagonal pyramid. Right, the number of edges. How many edges does it have, this octagonal prism? How many edges does it have?
Oh, 9.
Right, let's count, because now we're going to count 1, 2, 3, 4, 5. Okay, then 6, then 7, then 8. So you have 8, then 9, 10, 11, 12, 13, 14, 15, 16. Okay. So in other words, we have a total of 16 edges. There are 16 edges because you're going to count this edge, that edge, that edge, that edge, that edge, that edge, and then now you go and count also the bottom ones. So you see, you counted 8, and then you count 9,
Oh.
10, and then up to 16. So the total of 16 edges. How many faces are there?
So can you erase the numbers here?
Please come again.
Can you erase the numbers?
These numbers, eh?
No, so the numbers on the pyramid.
All right, the numbers I've written here. Yeah, okay, yeah. Because now they're destructive, right?
Yes, sir.
Yes, I can erase them because they make it a bit unclear. Yeah. All right. Let me just erase them. Let me just erase them. Right, so I've raised them. So how many? How many do you think?
9 faces. Wait, no, 10 faces.
Okay. Let's check. Okay, so you're gonna have 8 faces on the sides, like 1, 2, 3, up to 8 on the sides, on the slanted sides, and then the bottom is gonna be like 1 face. So the total of 9 faces. How many vertices are there?
Vertices. Size at 18.
Okay. How did you know that number?
So I had to multiply the number of faces.
Okay. Think again, please.
Oh wait, is it 9 vertices?
Yeah, definitely. It is a total of 9 vertices. It's a total of 9 vertices. Okay, so you note that one. You note that one. We continue and we analyze more. Okay, now we look at the transformations. This one's here. 3.2. Are you able to see the transformations?
Yes, sir.
All right. Which transformation took place in each of the following diagrams? There's A, there's B, there's C, like that. What transformation took place for these to become that? These to become that. Okay, let's start with A. For these to become that, what kind of a transformation is this? What happened?
So is it reflection?
Excellent. It's called a reflection. It is called a reflection. This one.
So rotation?
Excellent. So it's just a rotation like that. Just a rotation. This one now. C.
Translation?
Please come again.
Translation?
It's called a translation. Well done. It's called a translation. Okay, now let's look at 3.3. Let's look at 3.3. Draw the reflection of shape WSI on the diagram below. Okay. All right. Right. So how is this going to be? Okay, I know that you just can't draw it on the screen yourself. So draw the reflection of the shape that in the diagram. Right, so the reflection would actually ordinarily mean a reflection in the y-axis. So it would mean a reflection in the y-axis. Right. So if you reflect in the y-axis, so there are like two steps here. You're gonna have two blocks here, 1, 2. So from the y-axis, 1, 2, then you're gonna have this 1, 2, 1, 2. Then you're gonna have a marking there, like so. And then now, how many steps down from this would count? 1, 2, like one block, 2, 3, 4, 5. 1, 2, 3, 4, 5. In which case, from here, 1, 2. Okay. And then now here, you can count diagonally just one across. So you're going to have this here. And then you're going to have something like so. In which case, therefore, you're going to have like W primed, S primed, P primed, I primed. So that will sort of be the sort of shape you're going to get. An average. An average, you're going to get that if you look at the reflection in the y-axis. Or a reflection about the y-axis. Next. Let's look at question 4. These triangles are similar. Triangle DF is 1/3 of triangle ABC. Give the length of EF. What's the answer? Okay, you let me know when you're done. You let me know when you're done.
So is it 9 centimeters?
Please come again.
9 centimeters.
Why? Okay, you say you can see EF, right? EF is this one. EF is this one. EF is this one. All right. And I mean, it corresponds with this side here. The longest side of this triangle. So, but the other sides, like this one, that one, correspond to this. But the triangles are similar. What are similar triangles? When do we say two triangles are similar? When?
Same shape, different size.
Yeah, same shape, but different sizes. Okay, good. Now let's continue. Then please give us the answer to 4.1. Calculate the length of EF. What do you think now the answer is there?
Let me calculate it. Where's my pencil? Okay.
What do you think the answer is there?
Still calculating. So it's 6 centimeters.
Well done. It is 6. How do you get it? It is exactly
So you have
6
to,
centimeters. Why?
so
Because
let's say
1/3. 1/3. So divided 18 by 3. You divided 18 by 3 because it's 1/3 of triangle ABC. So if you divide 18 by 3, 18 divided by 3 is what? It's 6.
6.
That's why it's 6. Okay. The length of AC. What is the length of AC? What is the length of AC? Are you able to see AC?
Yes, sir.
Okay.
Um, um, says it 24.
Okay. Why?
Um, didn't you have to
Okay.
say? Oh wait, nah.
Yeah, because for example,
Um,
this one is 6. Okay, if we are given 6, how do you get the one that was there before? Because it's 1/3. Here you divide by 3 to get 6, but if you move backwards, you multiply by 3. So 6 centimeters by 3 is what? Is 18. So you multiply by 3. 6 by 3 is what? It's 18.
18. Okay.
Same here. You have 4. So to go back, you must multiply. So if you multiply by 3, what do you get?
12.
You get exactly 12. So that's the answer. 12 centimeters. What is the size of angle B? The
So
size of
45.
angle B. Please come again.
Is it 45?
Well done, 45 degrees. 45 degrees. Okay, if you look at, name the triangle according to the length of each side. Name the triangle according to the length of its sides. Okay? What's the answer?
Is it an isosceles? I mean, no, a scalene.
Yes. It's called a scalene triangle. It's called a scalene triangle. Why? Because all the sides are different in length. Next, name the triangle according to the size of its angles. Name the triangle according to the size of its angles. Okay, what's the answer?
Is that an equilateral?
Equilateral means all the sides are equal and all the angles are equal. So, yeah, in this case, not.
Wait, is it an obtuse angle?
Yeah, it is called an obtuse. Obtuse angled triangle. Obtuse angled triangle. Right, so it is called an obtuse angled triangle. Why is it obtuse? Because we have an angle here more than 90 degrees. More than 90 degrees in the triangle. Okay. Next. Next. Okay, we continue. Section B, we have the perimeter area, surface area, volume, and capacity. Okay, so the shape below shows the border of a farmer's property. Answer the questions that follow. Show all calculations. Okay, so let's get cracking. If the perimeter of this property is 3 to 5, find the length of side X. Are you able to see the question?
Yes, sir.
Right. What do you think the answer is to the question?
Isn't it 72?
Why?
Because isn't it the same as oh no, not 72.
Please come again.
Isn't it the same as the other angle?
The same as which one?
The other angle that is the ones that are parallel to each other,
Okay, let's just check.
that are equal. Oh no, it's not.
All right. Are you able to hear me?
Yes, sir.
All right. Now to get X. What's your answer again? I need to make sure and you have it right.
72. I see.
So in other words, to get X, you need to say X is this one.
I see.
So X plus
Oh, I see what I did.
X plus 72 plus 77 plus 100. Okay. Like so. Is equal to 325. So you have 325 minus 72 minus 77 minus 100. So what's the answer? Getting that, I need to check if we're right. 325 minus 72 minus 77 minus 100, which is 76.
Wait, so mustn't it add up to 360?
Okay, because we're dealing with a perimeter. So perimeter means the sum of the lengths of the sides, but they've already said the perimeter is 3 to 5. So if we add all the lengths of the sides, X plus this plus this plus that, it must give us what? It must give us exactly 3 to 5. You get the point?
Yes, sir.
Because it's not the angles. X is a side. It's not an angle. So if it was an angle, it was going to add up to 360. Yes. But angles add up to 360, not the sides. You know?
Yes, sir.
So you have that. So next. Okay, next question. The owner of this property wants to put a fence around it. What would the owner pay if the cost of fencing is 340 5 rand per meter. What do you think is the answer to the question?
Wait.
Okay, let me know when you're done. Okay, so please let me know when you're done.
What?
Okay? You done?
No.
Okay. All right.
So it cost 2,200. Wait. Um. So. Oh no.
Okay. What's the answer?
Says it 224,250.
You close? You close to the answer. Right, what you need to do is to look at the perimeter. The perimeter of the property is 325 meters. The fencing is 345 rand per meter. You multiply this. 5 by 5 is 25. You bring down 5, then you carry 2. 5 by 2 is 10. Plus 2 is 12. You bring down 2, then you carry 1. 5 by 3 is what? Is 15 plus 1. It is exactly 16. And then you would put 16 there. Right, next you come to the number 4, the digit 4. 4 by 5. What do you get 4 by 5? 4 by
20.
5, you get 20. So you bring down 0. Bring down 0 and you carry 2. 4 by 2 is what?
8.
Is 8. 8 plus 2
10.
is 10. You bring down 0, then you carry 1. 4 by 3 is 12 plus 1.
13.
13. Right, next is 3. 3 by 5 is 15. So you bring down 5, then you carry 1. 3 by 2, 6 plus 1, 7. What did I do here? 3 by 5 is 15. Bring down 5, then you carry 1. 3 by 2, it's 6 plus 1, 7. 3 by 3, what do you get? A big 9. So you balance. Right, here you perform addition. Right, so if you perform addition, what do you get? Right, so you add 5 with the zeros. Here you have 11, you bring down 1, then you carry 1 here. Okay, here you have 11, 12, carry 1. 10 plus 1, 11. This is the answer. So we're asking the question, if the owner of this property wants to put a fence around it, what would the owner pay if the cost is this? So the owner pays 112,125. The owner pays 112,125. Okay. Next question. Calculate the area of the following shape. Show the formula for each calculation. Okay, I'm giving you a couple of minutes to find the area, please. What do you think the area is? What do you think the area is? And how do you find the area? We're looking at typical exam questions at the moment.
So is it 1,024 centimeters cubed?
How did you get that?
So you had to multiply the 6 times 16 times 8, then also multiply the centimeters gives you centimeter cubed.
All right. Obviously, at this point, to find the total area of the following shape, what you need to do is to perform a couple of computations. But you can see that this is called a composite shape. Composite shape. And therefore, this means the area is the area of the triangle, which is half base by height plus length by breadth. So area. So we use this formula because the top is a triangle. So if the top is a triangle, then we have base by height. Because this is 16, this is also 16 because the bottom is a rectangle. All right, it's rectangular in shape and we think it is a rectangle. So the top is a triangle. So we have the area formula to use for the triangle and then the rectangle formula to use for the base of the composite shape. So using that formula, what do you think the answer is to the question? Using that formula, what do you think the answer is to the question? You're done.
No, sir.
Okay. Okay, let me know when you're done, please.
Um,
Okay.
so I'm struggling a bit.
All right. What is the challenge there, Lindsay? Right, so this is sort of the height for the angle is 90 degrees there because we understand that the base and the height are perpendicular to each other. So if you look at the base is going to be this one with the triangle at the top. So 16 times the height is 6. the length of this rectangle is 16, and the breadth or the width is 8. So we have a rectangle here, and this one is the length, and this is the breadth. So right here, the base is 16, and the height is 6. So the area. So half of 16 is what?
It's 8.
8. Half of 16 is 8 by 6, 16 by 8. Okay, what is this? It's the area. What is 8 by 6?
48.
48 plus 16 by 8? It's around 128. Okay. Right, if you add 48 and 128, what is the answer?
176.
176. Did you get it?
Yes.
It appears that you're close to the answer. Okay, but that is the answer for the area of the composite shape. Okay, that is the answer for the area of the composite shape. Right, next question. Now they've given us, what do you call this shape?
Rectangular prism.
It's a rectangular prism. This one is called a rectangular prism. A rectangular prism. Right, so if you look carefully then, if you calculate the total surface area of the following object, what is the total surface area of the object in your view?
Says 2,560 centimeters cubed.
Okay. Please come again.
2,560 centimeters cubed.
All right. How did you get it, Lindsay?
Length times width times height. The surface area.
So the total
Yeah.
surface area. The total surface area is going to be, this one is the length, and this is the breadth, and this is the height. So which means you're going to have the formula is 2 into length by breadth. Okay. Something happened and this was just writing here. Let me just remove this. Okay. We are continuing. Right, so I was writing the formula, but there was just too much inking on the screen. So it's twice into the length by the breadth plus twice into okay, because it's going to be the length by the breadth, and then there's length by the breadth. Okay, so which means that length by the breadth is top, it's bottom and top. Then we have also the length by the height, 2 times. Length by the height, 2 times. Okay, length by the height. Then you also have twice into breadth by the height. So yeah. So if you have the length by the breadth, the length is 20 by the breadth is 8. 2 into. Now you have the length by the height. The height is 16, but the length is 20. This is nothing. 2 into the breadth is 8, by the height is 16. Then you get the answer, total surface area. Let's continue. So what is the answer there, Lindsay, if we just simplify, multiply everything? Right, the answer appears to be 1216. The unit here is the centimeter, so it's going to be exactly square centimeters. And that is the total surface area. Total surface area. Okay, note the formula that given a rectangular prism, the total surface area is this one. Okay, so it's twice into the length by the breadth, twice into the length by the height, twice into the breadth by the height. Okay, so that's the answer. Next question. Okay, let's check the next question. Study the cube given below and answer the questions that follow. What is the volume of this cube? Okay, because you need to study the cube given below and answer the questions that follow. Side measurements 40 millimeters. Calculate the volume of this cube. What is the volume of this cube?
40 millimeters.
Please come again.
40 millimeters.
Okay, let's check. Let us check.
Foot, oh no.
Let us check. Let us check. What is the volume formula? The volume formula is that V is side by side by side. Side by side by, so if this one is 40, then it's going to be 40 by 40 by 40. And what is the answer? Because the side measurements are 40, so it means the height is 40. This side is 40, and that is also 40. Effectively, the height is also a side. So the length of the sides are actually 40 millimeters. So you get 40. So 40 by 40 by 40 is the same as actually 64,000 cubic millimeters. But you can also convert this. Okay, fine. But you can also do it in centimeters. Yeah, can do it in centimeters because 40 millimeters is also the same as 4 centimeters. So here you can come and say 4 by 4 by 4, which means 4 by 4 by 4 is what? Is 64 cubic centimeters. Okay. You can also do your answer in millimeters, but you can also do it in centimeters. Any question?
No,
Any
sir.
question? No question.
No, sir.
All right, we continue. Okay, here's the question. How many liters of water can this object hold in liters? How many liters?
Um, liters.
Okay, you're done.
No, sir.
Okay.
Liters.
All right. So how many liters are there?
How do I?
Please come again.
So I'm trying to calculate how many liters the
All right,
pig
all
can
right, that's
take.
fine. We have enough time to do it. We are practicing here. We are practicing. We are practicing. Practicing.
Um, I'm struggling.
Okay, too easy.
You don't really get it. Is it 64 liters?
Please come again.
64 liters.
Okay, good attempt. Right, you need to know that 1 liter is 1 million. One million cubic milliliters. 1 liter is 1 million cubic milliliters. So now, if we convert, we do what? We divide. So if you divide 64,000 by 1 million, what do you get? So you're going to divide 64,000 by 1 million. So here you divide, it's like dividing by 1,000, so you can put some zeros here like this. But now this 1,000 has 3 zeros, so you move the decimal point 3 places to the left. So 1, 2, 3, like so. Okay. Like that. So it's 0, you can put a point, but it's 0,064 liters. 0,064 liters. Okay, that's the answer. Next question. In your own words, explain the difference between volume and capacity. In your own words, explain the difference between volume and capacity.
Volume is
Volume is what, and then capacity is what?
volume is how much it is. How to explain volume?
Okay, there's a difference between volume and capacity quite in the way they're defined.
The amount of space inside a 3D object.
Okay. Please come again. You said what?
The amount of space inside a 3D object.
Yes, volume is the amount of space inside an object. Okay, what about capacity?
How much a 3D object can hold?
Yes. How much substance? How is how much? Put small h here. is how much substance can fill a space inside an object. How much space can fill a space inside an object? All right, if you look at number 5, below is a diagram of Peter's garden with a swimming pool in the middle that measures 8 meters by 5 meters. The shaded part is where he wants to plant grass around the pool, 18.5. Okay, so below it's a diagram of Peter's garden with a swimming pool in the middle that measures 8 by 5, 8 meters by 5. So we have a swimming pool in the middle and we have those dimensions 8 meters by 5. The shaded part is where he wants to plant grass around the pool. So he wants to plant some grass around the pool. Calculate the area of the shaded part. Okay, giving you 2 minutes to try that one, too easy. What is the perimeter of the shaded part? Okay, let me know, please, when you're done with the swimming pool. Let me know when you're done with the swimming pool.
What? Calculate the area shaded part. So it's 28.
Please come again.
Is it? No. 40. 56 meters.
Okay, how did you get it?
So you had to add up the sides.
Okay, because below it's a diagram of Peter's garden with a swimming pool in the middle that measures 8 by 5. So it measures 8 by 5. But this one is 18. So what is the meaning of these now? If this one is 10, so this one is 8, and this one is 5, and this one is 18. So, okay, if this one is 5 here, and this is actually 10, and this is sort of in the middle, what is the meaning of this here? So you have two areas to, you have the big rectangle and then the small rectangle. Okay. So area, big rectangle. Area, small rectangle. What is the area of the big rectangle? Right, the area of the big rectangle, the formula says length by breadth. Also the small rectangle, the formula says length by breadth. What is length of the big rectangle? Right, the
18.
big, the big rectangle, the length is 18 by 10. What is 18 by 10? It's 180. That is square meters. Length by breadth of the small rectangle. The length is 8 by 5. 8 by 5 is 40 square meters. Area of shaded part. Area of the shaded part is going to be different. So you're going to take 180 square meters. You can just put that right here. Minus 40 square meters. What is 80 minus 40? 140. So it's 140. So the area of the shaded part is just, you take the outer one and then you minus the smaller one inside, and then you get the area of the shaded part. Okay. Okay.
Yes, sir.
Right, next question. If the grass costs 30 rand per square meter, how much will Peter have to pay for it? What's the answer? What's the answer? Okay.
So that's a 240 rand.
Please come again. What do you think is the answer to the question?
240.
Let's check. How did you get it?
So we had to divide the 140 meters squared by
Right. So obviously, if you want to find the costs, you want to find the what? The costs. You always multiply. You always do what? Multiply. So you take 140, which is the area, you multiply by the 30. Like that. Right. If you multiply by the 30, what do you get? So you need to multiply 0 by 0, 0. 0 by 4, 0. 0 by 1, 0. 3 by 0, 0. 3 by 4, You get a 12, you print out 2, then you carry 1. 3 by 1 is 3 by, you add 4. Zero, zero, 2, like this. So yeah, 4,200. So the cost is 140. So the cost is 4,200, like we did before. Like we did before. Okay, so we continue. We continue. What is the next question, Lindsay? The next question is on data handling. Underline the correct terms that describe the graph below. Which one is the answer, Lindsay?
What is this? Says it linear.
Why, Lindsay?
Because
Okay. Yeah, what's the answer? I'm still sort of waiting.
so I don't think we've really done this work this year.
We haven't done this one.
No, sir. It's not on the this.
Okay. But it's too obvious. What does linear mean? Ordinarily, a linear graph would be this, called linear. Linear means straight line. And then there's a graph that is like this. When x increases, if this one is the x-axis and that is the y, so x increases, y decreases. If x increases, y decreases. So which one is the answer, Lindsay?
Says it non-linear.
Yeah, definitely. It means that it is non-linear. It is non-linear, but also when x becomes very large, because you have maybe x is 1 here, maybe x is 2 there, maybe 3 there, maybe 4. Then you have 1, 2, 3, 4. Okay, so this is x and this is y. So when x increases, y decreases, and is said to be decreasing. Said to be decreasing. It's said to be decreasing. But a graph like this would be what? When
Increasing.
X increases, Y also increases. Is it linear or what, this one? Or non-linear?
Non-linear.
It's non-linear. It's non-linear. But is it increasing or decreasing this?
Increasing.
It is increasing. It is increasing. Next question. Draw a line graph of the rainfall in Cape Town over a certain year. Use the rubric to assist you. Okay, here is it. Here it is. Like in January, the rainfall was 10. In February, 5. Okay. So we continue. So let's draw the graph. Like in January, so you need to draw some Right, so if you check, we're gonna have something. Like so. Okay. And then here you're doing 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Okay. If this one is January, February, March, April, May, June, July, August, September, October, November, December. So January is 10. So you're going to put 10. February is 5. March is 3. April is 12. May is 30. June is 76. June is 75, then just 76, you're above there. Okay. Then July is 90. July is 90. July here is 90. August is 70. August is 70. September is 50. October is 35. October is 35. 35 is here. October. Next. November is 20. 20 is here, then go to November. December is 12. So which means that you're going to do this. Okay. Can I just join the points like that? And that is the answer. So that is the graph. So you're just supposed to draw this graph. And we've just drawn this graph. This is the annual rainfall in Cape Town. The caption of the graph is the annual. The title of the graph is the annual rainfall in Cape Town. There in Cape Town. Next question. Study the graph below and answer the questions that follow. Which item is more popular with the foundation phase than with the senior phase? Because with the foundation phase and the senior phase, you can see that the foundation phase is at here is at like between 40 and 50. There is also the senior phase at 60, and then here you have the foundation phase at 40, and so on. Okay, which item is more popular with the foundation phase than with the senior phase?
Knickknacks and lollipops.
Please come again.
Knickknacks and lollipops.
Okay. Why?
It's more popular with the foundation phase. No, it's Spookies and pizza.
It's the Spookies. It's the Spookies. Well done. It's the Spookies, because the Spookies are said that they are more popular with the foundation phase than with the senior phase. Okay, so it's not really the knickknacks, because the foundation phase is this one. So they're more popular with the foundation phase than with the, because you can see the foundation phase is taller, but here the foundation phase is shorter with the knickknacks. But here it's taller. So yeah, more popular the Spookies. Okay, there. Okay. And you can see it's taller here, but here is not as tall with the pizza. But obviously pizza would as well potentially do. But we're looking at more popular, and the Spookies are more popular. Okay, next. How many more lollipops do the learners in the senior phase buy compared to the foundation phase? Get the question. How many more lollipops
Yes, sir.
do the learners in the senior phase buy compared to the foundation phase? Okay, how many more lollipops? What do you think?
So 15.
Mm-hmm. What did you get?
15.
15, right? Because this one, obviously, you're going to get 50, because this one is sitting at about 50 of the lollipops, and then this one is sitting at about 35. And the difference is 15. So it's correct to say 15 more lollipops. 15 more lollipops. Next question. How many items did the foundation phase buy altogether? How many items did the foundation phase buy altogether? What do you think? How many more items did the foundation phase buy altogether?
So 145.
Please come again.
145.
145. Well done. Because yeah, you're gonna see that the foundation phase are the darker ones. So you can see that here they are 45, and here they are 40. Here they are 25. Here they are 35. And the answer is 145. So surely it's correct to say how many items in the foundation phase buy altogether? So this is like 45. This is 40. This is 25. And this is 35. So the foundation phase bought 145 altogether. Next question. Arrange the following marks in ascending order. What's the answer? What is the smallest mark?
3, 3,
3. After 3 is what?
6,
After 3 is 6. After 6 is what?
7,
7. After 7 is what?
11,
11. After 11 is what?
12,
12. After 12 is what?
15,
15. After 15 is what?
16,
16. After 16 is what?
19,
19. After 19 is what?
so there's another 19.
Please come again.
So there's another 19.
19 again. So that's correct. So how many digits are there altogether? How many numbers have we put? So okay, so we have 2, 4, 6, 8, 9, 2, 4, 6, 8, 9. So yeah, with all of them. What is the median mark? And why? What do you think the median mark is and why?
Mm. 12.
Why?
It's in the middle of the
It's in
set
the
of
middle,
numbers.
right? It's in the middle because if you look at the 12, then we have 2, 4 this side and 2, 4 the other side. So 12 is in the middle, so it's sort of the middle number, and therefore the median mark is 12. What is the range, Lindsay? What is the range?
It's like 16.
How did you get it?
So you have to subtract the smallest number with the biggest number with the smallest number.
So the range is what?
16.
So yeah, that's correct. To say the range would be 19 minus 3, which is 16. So take the largest one minus the smallest one, which is 16. What is the mean mark, Lindsay? The mean mark. What is it?
So 12.
How did you get 12, Lindsay?
So I added up all of the numbers, which gives me um
The 9 of the numbers,
100. It gives you 108
it gives 108. And
divided
divide through
by
by 9, and what do you get? You get
12.
12. That's correct. And so the mean mark is what? The mean mark is 12. The mean mark is 12. Next question. The mean mark is 12. The mean mark is 12. Okay, next question. A coin is tossed 10 times. It landed on heads 4 times. Calculate the relative frequency of it landing on heads. Okay, so what answer do you get?
So it landed on hits 4 out of 10 times.
Uh-huh. So what is the relative frequency of it landing on heads? What is the answer?
Relative frequency.
All right, you already given me the answer, and you said the answer is going to be it landed on its heads 4 times, so it's going to be 4 out of 10 times, right?
4 out of 10 times.
Okay. Which is 2 out of 5. Can simplify this. We can give this, or we can give it the other way around. We can say 10 to 4, 5 to 2 ratio. Like that. So you can give it like that, 10 to 4, 5 to 2. Or this one, 4 to 10. The ratio of 4 is to 10, or the ratio of 2 is to 5. Like that. And that is the end of the question paper. Any question? It was
No,
380 marks. Okay, total of 80 marks. Any question, Lindsay?
No, sir.
No questions. So we did this paper here and went through all the questions and discussed together. So this was an exam that was written as Mathematics Paper 2, 2019 by the grade 7s, 2 hours, total 80 marks, moderators and the examiner. Thanks a lot for joining us today. I will see you again tomorrow. Okay, my expected time is 4 p.m. So yeah, I think I'll see you tomorrow at 4 p.m. Okay, but you let me know if you're busy, then we can meet later. You know?
Okay, sir.
All right. Okay. Thanks, Lindsay. I'm gonna send the video recording in the next couple of minutes. Goodbye.
Hi, sir.
Goodbye, Lindsay.